Alright, so this is the last part of chapter 2. It's on acids and bases. It should be relatively short. When you make a solution of water, you can possibly make it acidic or basic. And pH is a measurement of that. One way we can measure it is to measure hydrogen ion concentration. So water some of it will ionize. So it will separate into ions. The OH is called a hydroxide, and it is negatively charged. The other part of that, the positive part, is just a hydrogen by itself with a positive charge. So this hydroxyl group has taken the electron from hydrogen. Remember, hydrogen only has one electron. And that means that hydrogen is positively charged. You can also add well, let's not get into that. But we're going to be measuring the concentration of this. How much of this is in solution, the hydrogen ion. Anything that increases this is an acid. So acids will increase the hydrogen ion concentration. Anything that decreases this is a base. And pH is a measurement that can tell us whether something is an acid or a base. And essentially we're measuring the hydrogen ions, the number of them. The pH scale, pH mathematically is the negative log of the concentration of hydrogen ions. So this negative means it's an inverse relationship. So as pH goes down, the number of hydrogen ions go up, and that is acidic, or more acidic, as we go down in pH. As pH goes up, the opposite is true. Your hydrogen ions go down, and it becomes more basic. or alkaline. And then the log scale means it's nice numbers from 0 to 14. Again, anything low on the scale is acidic, which is what I just went over here. Anything high on the scale is basic, and alkaline is just an old-fashioned term for basic. And then right at 7 is neutral. Around 7 is mostly neutral. And that's the pH scale. Each difference in the pH scale, so 0 to 1, 7 to 8, 13 to 14, that is a factor of 10. So if I ask you how much more acidic is a pH of 4 versus a pH of 5, that's only one step, so it's 10 times. A pH of 10 is more basic than a pH of 8, 100 times. So if you go 8, 9, 10, 10 to 9 is one step, 9 to 8 is one step. Each step is 2 tens. 10 times 10 is 100. When there's 2 tens, there's 2 zeros, so it's just a 1 with 2 zeros. If you're looking at pH of 7 versus 10, that's 1, 2, 3 tens. With 3 tens, there's 3 zeros. So it's a 1 with 3 zeros, which is 1,000. So a pH of 7 would be 1,000 times more acidic than 10. The pH of 10 is 1,000 times more basic than 7. So be able to do that. Your pH value can also tell you your value for the hydrogen ions. So if your pH is equal to some number, then your concentration of hydrogen ions is equal to 10 to the negative x. So if your pH is 3, then your hydrogen ion concentration is 10 to the minus 3. If your pH is 14, then your hydrogen ion concentration is 10 to the minus 14. And the higher your negative exponent is, the smaller the number. Conversely, you can figure out the number of hydroxide ions, which would be another way to measure pH. So if your pH is X, then your hydroxide ion concentration is equal to 10, I'm running out of room, to the negative, let's do parentheses, 14, because our scale goes to 14, minus x. So if our pH is equal to 3, then your hydroxide ions are 10 to the negative, what's 14 minus 3? 11. So then your hydroxide ion value is 10 to the minus 11. If your pH is 5, 14 minus 5 is 9. Your hydroxide ion concentration is 10 to the minus 9. If your pH was 10, 14 minus 10 is 4. Your hydroxide ion value would be 10 to the minus 4. So now to do those three maths, be able to calculate the concentration of hydrogen ions, be able to calculate the concentration of hydroxide ions, and be able to compare more acidic or more basic if I give you two pH values. Also know our equation, and know that these brackets just mean concentration of. So the pH is negative log of the concentration of hydrogen ions. You need to also know some examples. So lemon juice and stomach acid are very acidic. Tomatoes and coffee are somewhat acidic. Milk, pure water, human blood are right around neutral. Baking soda is slightly basic. Oven cleaner and ammonia are fairly basic, very basic. Both extremes are dangerous, or can be dangerous. They can be caustic, and they can burn your skin. They can also cause irritation, extreme irritation to eyes. It could cause you to go blind if you got oven cleaner in your eye, for example. Or stomach acid or car batteries are pretty acidic too. So that's another thing you don't want to get in your eyes. They can also irritate your airways, so you want to be well ventilated when you use any of these caustic items. A buffer is something that maintains a certain pH value no matter how much acid or base you add. Now there are limits to it. You could overwhelm a buffer, but in general they resist pH change. They're going to keep pH at a certain level. Your body keeps human blood right around 7.3, 7.4. And in your body you have a buffer we make from carbon dioxide and the water in your blood. So when CO2 and water mix, you get an acid. And the way I don't have this memorized, I just add it all together. So there's 2 hydrogens, 1 carbon, and 1, 2, 3 oxygens. And that can ionize into hydrogen ion and bicarbonate. And also, I don't have bicarbonate memorized. I just subtract 1H from this, and the rest is bicarbonate. I just got to remember to do the minus sign, and that's pretty much it. So this is your buffer system in your blood. Buffers are typically a weak acid and a weak base, which is known as a conjugate pair. If your blood gets too basic, the acid will neutralize it. If your blood gets too acidic, the base will neutralize it. So that's how your body prevents pH changes in your blood. It's one of 3 mechanisms. You can also affect your blood pH with your breathing rate, and your kidneys also have some function in controlling your blood pH. But this buffer system is typically the first step, and it prevents acidosis and alkalosis. Acidosis is more common when your blood gets too acidic. It happens when you're starving yourself. It happens when you're drinking too much alcohol. It can happen when you're having a diabetic episode. But for any of these, if it gets too bad, you can go into a coma and you can possibly die. So this buffer is very important. It keeps blood right around 7.3 to 7.4. Slightly basic. So this is the last slide for part 4. Y'all have a good week, and let me know if you have any questions.